from our tech point of view, we're relatively new on down a route where we've kind of been given free rein. We're going to build a new estate. Can we replace our current e-commerce platform with a new one? Do what you want, build it how you want, where you want. Essentially a blank check, crack on, give it a go. Which is what we're doing. So we've been doing that for a little while. So we had a greenfield environment. We could do what we wanted. We wanted some sort of single consolidated platform. We trade in about 50 countries around the world. Lots of them have their own cookie cutter setup. Most of it's in Google. We use GCP for a lot of things, so they have their own infrastructure in every place. We want to try and unify that, have one single global infrastructure that you can log in anywhere you want, place an order to any country, and so on and so forth. We want it to be extendable. Lush, move quick. Some people might be familiar with an outage we had last week with Tills, I think a couple of weeks ago. Big backlash from that in the tech community. You hit Reddit, and there's a lot of people slagging us off. Why would your engineers ever allow that to happen, et cetera, et cetera. We go quick and we fail quick, and it's like, if we don't do it quick, like, we'll be 6-12 months behind where we want to be. So we'll give it a go. That's kind of a company-wide mentality. From product design to being on the shops can be days sometimes. And then anyone who does know our products, they may last a week and then they've gone again and you won't see them again. We're constantly trying to push as quick as we can to do things. So we want to be extendable, so we don't know what's coming. Scalable, reliable, maintainable. It's all the buzzwords. Everyone knows these things. That's what we want. That's utopia. It's got to be easy. Minimal instructions development. Again, kind of the new world. The devs write the code. They just deploy it to prod. They know what they're doing. They know the applications. Why do I, as an ops engineer, need to sit in the middle so much? If I can just trust them to, if it breaks in the middle of the night, they take responsibility for it. I'm more to provide the pipelines to get it there, to hold their hand and get it through. Polyglot platform. Basically, we've got developers. Historically, we're a PHP house. We're pretty much 100% Golang now in Pool. We've also got a Java team out in Korea. So whatever we had, we needed to be easily to onboard other people in different languages and try and move as quick as we could. I'm keeping an eye on that time because, yeah, I might have to cut short a bit. So of course we naturally fell. We sort of looked around and we realized that things like microservices, Docker, Kubernetes, GK, all these buzzwords, it kind of fits what we wanted to do. We wanted to be able to spin up small components really quickly, rapidly, get them out there. So this is an incredibly high-level overview of one section of our infrastructure. So this is kind of the back-end area. You've got the front-end stuff that you look at, and then you've got your back-end. Of course, API gateway, that's responsible for kind of just validating requests. There's bits of security all bundled in there. And then we've got lots of services. So at the moment, we've got about 300, I believe, the last time I checked. But what you'll notice is that one service, one database. Pretty much every microservice we have has its own database. If it needs one, not all services do. Some things will just do it on the fly, send response back. But part of that basically means we don't have such dependency issues that you quite often get if loads of services are sharing databases and you suddenly want to change one and it breaks something else and so on. We didn't want a distributed monolith. We wanted microservices, which is what we've got. Some databases use SQL, some are using Google Spanner. I think some have Mongo. They might have gone now, actually. So this is kind of, what is this slide? Okay, this is just a quick guide of how we deploy stuff, just in case people are interested. I know I always like to know how other people are doing things. Devs push to Git. It's my foo service.git. We then kick off a build in GitLab using a runner. That's on master branches, master and all other branches. They then kicks off another stage in GitLab, which is deploy to stage. Part of that says, do you need a database? If you do, I'll quickly call Google and create you one. So if a service needs a database, you know you're not going to break anything else then. Of course, those databases can be branch related, it could be feature related. It's all in the naming conventions, tags, things like that. So then we deploy to just our internal stage environment. One nice thing to notice is it's HTTPS. Everything is SSL. We're using Kubernetes, therefore we've got Let's Encrypt pretty much for free. And then we deploy our view service stage. A nice thing that we do is if the devs then check out our foo service. They branch the code, they make some changes, they push it. Those branches also get deployed. I pressed the button. Those branches also get deployed to stage environment. So you can see the sort of a naming convention we go with is just got the service, branch name. Ooh, look at that. Yeah, there. And then sort of random alphanumeric strings, just so we don't get any conflicts. And then this is the traffic coming in on stage. So devs can then hit every service individually if they want to. They can see how it would have deployed. They can see how it deployed into stage, and fingers crossed that pipeline should be exactly the same going forward. Slight differences when we come to prod. Devs basically tag it in Git. Simver, so we've got major, master, patch. Major, master? Major, minor, patch. Build is the same, it's the same command. We then also deploy to stage. If you notice, we're now deploying, we basically deploy to another endpoint, which is it takes the master version. So we have a master release endpoint where we can see that tag. This is pretty much the only manual step. Someone just says, yes, I'm happy with that. This gets QA tested, devs do what they want. And if they're happy to go to prod, then they hit the button. And we push through to prod. Very similar situation. You can see that we use the major release. There's a prefix for our service. The moment a new major release comes out, so when V2 gets created, that gets deployed in addition to the other one. So anyone who was using V1, of course, in reality, this all comes through the API gateway before you get here. You're kind of routed through. But if you're using version 1 of a service and some devs create a breaking change and they roll out V2, if you don't need the functionalities in V2, you just keep using V1. We just run them in parallel. Most of our Golang apps are kind of sub 10 meg. They're small components. They spin up incredibly quickly. We just leave them running, basically. And then we've got a bit of monitoring on request rates, things like that, so we can try and remove older services if they're obviously not being used. We also just deploy kind of an version, which always points to the greatest major release. It's kind of always the newest version. Yeah, I told you it's got a pretty black and white, plain slides. That's as far as I go. So that's our GitLab pipelines in as simple as they can get, really. Of course, those pipelines apply to all languages. If you need a database, then there's just a few extra handles that kick in and create you a database, create the user. And when you're finished with that, if you delete a branch, it then does the reverse and just destroys everything behind it as well.
How do you control? I'm always curious about this. Who can deploy to prod? Is there a separate approval process there? You're running some kind of automated testing, and then somebody goes, can anybody deploy to prod?
Currently, the devs, I think it's just like the senior dev guys basically have the ability to hit the button.
So this is now the prod branch and the way it goes.
Once it's tagged in Git, then it's kind of a snapshot. That is VX. That will get deployed all the way through stage as kind of on its own. But
is this one of those things that is like namespace in Kubernetes or something? What's the separation?
Yeah, I can show you that in a minute actually. But yeah, the major releases get their own namespace as well. So this is that's the GitLab kind of virtual side of how we deploy. This is kind of more what's actually going on behind the scenes. So we use GitLab.com, the hosted solution, as I mentioned earlier. For those who don't use GitLab, basically they've got the concept of runners, same as sort of Jenkins runners, things like that. They work on a pool basis. So this client runs, it's polling GitLab.com, and then it's if there's some work to do, then it does it. So basically, the devs push to Git. Up here is the GitLab runner daemon. This is always running. This is actually a Kubernetes cluster of its own, running in our utilities sort of area. It's a kube cluster running. It's actually got 3 runners, but to be honest, one would probably do the job. They're polling GitLab. It sees that there's some work to do, and it actually then spawns another pod in Kubernetes. It creates the GitLab runner environment, which is kind of, it spins up an instance of an image that we give it and checks the code out into it and does all the stuff that you'd expect it to do in GitLab. So, of course, that runner then talks to GitLab, clones the code, and checks what it needs to do. As part of the build process, we build this Docker image of our microservice. We use Google's GCR registry. I think it's the same as Amazon's ECR. It's just somewhere to host those Docker images that's kind of outside of our estate, somewhere sort of neutral that can be used to deploy later on. We use Helm currently to deploy to Kubernetes. So the Helm charts live, again, in a repository. It's kind of, there's one for a Golang app, there's one for the Golang plus MySQL, kind of the base types of services we may have. If then someone comes along and say they want to write it in a new language, then we just kind of spin up a new template that can deploy it, and a new Docker base and so on. And Swagger, so we push the API documentation goes there. That's what the front-end devs can use, the mobile app developers. That's how they can check their API contracts and what they need. So that's essentially the build phase done. You build your Docker image, you push up to GCR, you push it, there's a Helm chart, any Swagger dockers need updated. The next stage, of course, in Golang is the deploy. Pretty much exactly the same thing happens. If you haven't used Golang runners, they're really easy to do this stuff. You essentially, you do the same thing, it spins up a runner, it dials home and says, oh, this time we're on the deploy job. The only difference is this runner knows to run the Helm install command. I'm just going to talk as if people know what these things are. If you don't use Kubernetes and Helm, give me a shout later and we can talk about it. But I know I'm conscious I haven't got a lot of time. So the runner does a Helm install, pointing at our stage Kubernetes cluster. That Helm install says, here's the template to deploy into Kubernetes. Here's the name of the Docker image you need. So it can pull them down from the repo and they get run. Demo. Right, I'm on 15 minutes. This might work. We'll give it a go. I can't see that. That's really annoying, isn't it? Oh, you're on this one now. So I've created today just a really simple, it's called DevOps demo. It's a really simple, move around here a bit. Yeah, it's a really simple Go app. It's based on, we have a Go template app, which is just a hello world app that contains kind of everything it needs. The main Go code, of course, lives in that service directory there. But that's not super important. If we look at, let's get command prompt up. Ooh, hello. Where are you? So, switch to utils. So as I was saying earlier, so those who aren't familiar, this is actually a namespace inside a Kubernetes cluster in our util environment. So it's running 3 GitLab runners. They're the same as the runners you'd run on sort of bare metal or on a VM. Or the only difference is these are Kubernetes pods. If one of them dies, it just respawns and gets created somewhere else. If we were to, we're going to kick off. This resolution is not as high as I was hoping. Of course, you can't see that. All I'm doing here is just kicking off a GitLab pipeline as if someone had just pushed to master. The build is, I've removed all the tests, like the unit testy stuff, just to get it through a bit quicker. But what's going to happen is we should see, there we go. So a runner has appeared in our cluster. So one of these has basically polled GitLab. It realized there was a job to do. It's created a pod. That was the bit that was having issues with uppercase characters, but don't need to worry about it so much. And fingers crossed, here's basically the output. This is what was happening inside of that pod. So it's basically spun up a brand spanking new build environment with nothing in it. The only tools it has at its disposal will be the Docker image that it was told to run all of this inside.
The Docker image, what's the output of that build?
Of this one? We're using Docker in Docker. GitLab have pages and pages of documentation on how to build Docker containers inside a Docker environment. I won't go into it now, but if you really want to know, we can have a look at it later. So essentially, this is just running a Go build, it's downloading the dependencies, and then it does a Docker build, which for Go is actually quite simple. Of course, you compile your binary, drop it into an almost empty Alpine base image, and then it uploads them. So if we look at the GCR registry, we should have DevOps demo. So there we have a Docker image in a registry, just as it would be in Docker Hub if it's public. The only difference is it's restricted. So we've got access to it. Nice thing that Google recently rolled out for everything is they will automatically vulnerability scan all of your Docker images that are stored in there as well. I think the APIs are they're relatively new, but you can get alerts on if images have contained vulnerabilities. I think the image has to be built using either Alpine or Ubuntu. But that's another nice thing that they chuck us.
They're using Claire.
I'm not sure. I don't know. I would have thought so. So going back to our pipeline, oh man, no, I should have stopped this before it ran because it's probably just run the next stage without you seeing. It did. Of course, then it automatically went on to stage 2. I haven't got time to clean it up, but I just proved you that's what it did. But essentially what this ran was a bit of logic to say where you're deploying to, it connected to the kube cluster. Then it ran a Helm install, and it passed in the Docker like the registry name, the version of like the image to deploy. And if we switch to stage, you're gonna have to take my mind. You're gonna trust me when I say this didn't exist earlier. This is a namespace called DevOps demo. As part of that Helm install, it basically created a namespace and it just said, spin me up 3 of these pods. Now, these are incredibly simple because it's a Golang app with no dependencies on databases or anything like that. If it was, the only difference is we use sort of side-loading containers. And if you don't know about those in Kubernetes, again, give me a shout. But the idea is that you run your application and a MySQL proxy alongside each other locally. Your app can talk to localhost 3306, and it's actually talking to another Docker container, but they appear on the same IP. And then that's a proxy through to Google's SQL. Not sure if Amazon do anything similar. I know RDS always used to be a bit of a pain to get through to the database. So this is a really nice solution for that. They create their own secure tunnel to the database. Then we have an endpoint that we could hit just to, let's see how much time we got. I don't know what time I started. Anyone know? Plenty of time. Just, I won't let George talk. Let's switch back to that one demo. This is really awkward looking up here. Let's just try then. We're going to clone that repo. I think I should already have it locally. So that was just the app, that's that code base we got there. We're on git master, so we do git checkout, I don't know, db test 1. We're a dev, we've come along, and we're gonna check out this microservice. Of course, because it doesn't have any dependencies on anything else, they could just run Docker Compose up here and run it locally, and because it's just a single app on its own with no dependencies, they can develop locally, test locally. If it needed a database, then the template base app just has a slightly tweaked Docker Compose that spins up a MySQL instance alongside it, so they can still test. Or they could deploy to Minikube. There's also commands in the make file that do the same deployment that I'm deploying to stage and prod to Minikube using the same Helm chart. So trying to standardize as much as possible. Whatever we do, it's the same code over and over again. So we now have, this should complain, yep. So what should happen here? As if by magic. Yep, so these steps are the same. I'm not going to go into it. All it's doing, it's the same Go build again. It's going to push the container, or we could watch it. Won't take long. This is essentially just doing the Go dependency pulling step. The template app actually contains, there's a library, it's on GitHub just called, I think it's in Lush Digital, it's just the microservice core library, which kind of contains everything just to get an API up and running with set known response objects in and out, and some sort of middleware layer and things that we've put out there. Right, so now it does do quite a few Docker pushes at the moment because for historical purposes I'm actually pushing back to a locally hosted GitLab instance. So it doesn't matter when the deployment happens, if it was still pulling from the old one, it still has the latest images. The code is all in gitlab.com, but we're still pushing Docker images back to both locations, which is why it takes a little while just to push them. And we also push a couple of tags, again, just for backward compatibility, latest and master. But of course, the push doesn't take very long because the layers are already there. It just says, yeah, already exists. So that's now we've got a new Docker image has appeared, DP test 1. And, I've done it again. I should have been on this page. Not at the moment. Something like the Java apps are pretty big. Some of them are horrible. I missed it again, but it's usually 16 seconds, so trust me, it did happen. In this namespace, it's now deployed that branch's code, and it's created a nice endpoint for it, which I should hit. Yeah, so that's just hello world, basically, microservice. Again, HTTPS, so it's all SSL. Yeah. What would normally happen then, I won't go into it, but we've also got another stage in the pipeline that says when this branch gets merged in, run the cleanup operation, which just basically removes that Helm install, just does a Helm delete purge, gets rid of the database if it created one, and it's all gone again. I won't run it now because it doesn't work. I must have broken it sometime today. So that's incredibly quick overview of kind of how we deploy stuff on a day-to-day basis. Just off the back of that, some of the learnings that I've been with Lush for about 18 months now. Some of the things I've noticed are keep it simple. Verbose isn't always a bad thing. It's quite easy when you do these things to create sort of golden images that can deploy everything, and it's all in one script with loads of really complex if statements and regexes that mean you can do anything, and then someone comes along with a requirement that you haven't catered for. Suddenly you've got to build a Node app, and it's just an absolute ball ache. Sometimes a little bit more configuration in each application isn't necessarily a bad thing. Maybe a few more flags in the GitLab pipeline file just to say deploy to this, go here. Don't automate well, it's still automated, but just you've got more control. Let someone else look after your artifacts. This is one I've learned from a colleague who works for, I don't know what I can say, a very big website, UK based, where they had a major outage where they lost their production cluster. They hosted their own Docker registry. As everything tried to come up, it then killed the Docker registry. That then killed the apps, and they just spent 48 hours trying to get things running piecemeal because they kept taking out themselves. We're not so restricted in things like finance. There's lots of legislation and restrictions that I don't know about. Maybe it's a lot harder, but we basically use Google's GCR to host it. They've got the infrastructure. They're really good at hosting Docker images and them being available all the time. Other options are, ECR, Docker Hub. Vendor lock-in, we use Google a lot. And I know a lot of people are fearful of, they want to do sort of multi-cloud, just trying to make it. Kubernetes does help in that sense, because as we know, you can lift and shift your Kubernetes cluster, you can put it somewhere else. We use Google. We're relatively small digital team. The more weight that we can give to them, the more heavy lifting they can do for us, the better from my point of view. I don't know how many people were familiar with the vulnerability in Kubernetes last Monday, the pretty horrendous 9.8 out of 10. We came in Tuesday morning, I was absolutely bricking it to an email from Google that said, we patched this before it went public, you've got nothing to worry about. I feel really sorry for the guys who have to maintain their own kube clusters and go through the experience of like trying to upgrade them and patch them and things like that. If it's not something if you're relatively new to Kubernetes, you follow documentation, you've got it up and running, you may not have considered so much about how do we keep this going, how do we fail over, how do we upgrade, all these things that take a bit of a back seat when the companies start throwing work at you to get it deployed and running. You may have noticed we use Helm install, Helm upgrade to deploy straight to the cluster. One of the things I've kind of noticed with that is Helm upgrade uses lots of variables to say what is it deploying. It uses like the Docker image, the version number, things like that. That's kind of you can't replicate that. You can't run it again without using the pipeline. You don't know exactly what the state of your kube cluster is. So one of the things we're looking at the moment is our pipeline will spit out Kubernetes manifests in their complete form, like with all the tokens replaced, ready to go, store that, then apply it. The idea being, if I lost GitLab, if I lost my Kubernetes cluster, I've kind of got a folder with every manifest of everything that should have been running, and I can reapply it straight away without having to rebuild stuff. Ooh, hello. Tony, your clicker's gone a bit mental. Very quickly, I think I've overrun. This is where we're working towards. We want a single platform in all countries, so we're going to need to start replicating this Kubernetes cluster in lots of regions. To do that, databases. Data is always the hard thing. How do you have a single database? So we're working with CockroachDB. Those who aren't familiar with it, it's an open source database. It's kind of spun off of the Google Spanner project. So we're working with them, trying to work out to basically have a single database that we can roll out clusters everywhere, and they all talk to the same database, and it should be replicated all over the globe. Automated. There's some other bits and pieces that we're looking at doing now. That's basically it. That was incredibly quick. If you want to know anything else, do let me know. I think I said on the slide on the meetup, I can talk about this stuff all night. That's how you get hold of me. And also, just another push for the Golang Dorset meet, which is on Wednesday night in Westbourne with Digital Eagles. So feel free to come along. Even if you don't have to be a Go expert. I'm not a Go expert. The other two guys are. They will do the in-depth stuff. If you just want sort of Hello World basic and just what is it all about, then come along. Whew. Thank you very much.